Look at a typical massive enterprise network. Every new channel, web, app, CRM, AI, is built with its own direct connection to the back-end database. This is a spaghetti architecture. It forces developers to build and maintain redundant process logic for every single channel individually. Writing the exact same logic over and over creates heavily siloed engineering teams and generates massive technical debt. For the user, this translates to inconsistent, fragmented experiences across platforms. For the business, it results in dangerously slow time to market for even the smallest feature updates. To achieve actual omni-channel capability, that entire tangled web has to go. It requires a completely and ruthlessly decoupled architecture. We are going to construct a build once, deploy everywhere enterprise model from the ground up. By the time we reach the top layer, this specific build will demote the CRM and enable dynamic AI agents without training a single custom model. Breaking the hard-coded link between user interfaces and business logic is the only way a massive enterprise can survive accelerating technological shifts. The absolute bedrock of the enterprise lives here, the data layer and core operational systems. These foundational systems, managing checking, mortgages, and credit, are the isolated engines that execute the final, raw transactions. Directly above them is where raw data is managed, the business logic layer. This central layer manages strict organizational rules, compliance limits, and operational orchestrations. Inside this layer operates a critical mechanism, the actor context. The system must dynamically recognize exactly who or what is triggering a process before it executes. A client using self-service, a banker acting on behalf of that client, or an AI agent all trigger the exact same underlying transaction logic. Actor context enforces their different permissions. A human banker might have clearance to override a standard transfer limit, while an AI agent interacting with the identical workflow cannot. By verifying the actor before executing the code, the enterprise preserves the reuse of a single business process without sacrificing security or varied degrees of freedom for different users. Above business logic sits the fourth level of the stack, the shared digital process layer. This layer acts as the orchestrator. It explicitly defines the required fields, state changes, and validations for a workflow, step by step. The core architectural rule applies here. This complex process sequence is built exactly once. It outputs to two distinct paths. Interface 1 on the right is for human-readable renderers. These renderers provide standardized visual UI configurations, pushing the correct buttons and text fields directly to web and app platforms. Interface 2 on the left generates machine-readable APIs and schemas. This schema provides a real-time structural blueprint of a transaction's current state and identifies exactly which variables are missing. By splitting the logic output into raw schemas and visual renderers, the underlying business process becomes completely agnostic to how it is ultimately viewed. That brings us to the final top layer, the front-end channels. This layer changes the structural role of the CRM. Instead of functioning as the primary hub for data and logic, platforms like Salesforce move to the edge of the architecture. In this model, the CRM is stripped of its status as the process owner. It is merely a consumer workspace, a front-end shell that renders the shared process for the human banker. Stripping logic out of the CRM prevents vendor lock-in. An enterprise can theoretically swap out its CRM provider without rewriting a single core banking workflow. On the opposite side of the stack sits the AI channel. This AI agent contains zero hard-coded knowledge and utilizes no bespoke models regarding specific banking products. It acts purely as a generic linguistic mediator, reading the API schema in real time. Here is the real-time loop. The AI pings the API. The schema reveals that a required field, like an ID number, is missing or is returning an error. The AI translates that technical API gap into natural language and asks the user a direct question. When the user answers, the AI translates that natural language back into structured API data and passes it down into the process layer. Treating AI as just another schema consumer means the enterprise never has to retrain AI models when banking workflows are updated. Bringing all these layers together demonstrates the operational reality of being decoupled by design. Consider a hypothetical scenario. A bank needs to add a new compliance check to a wire transfer. The update happens exactly once in the shared process layer. That single change instantly propagates outward without any channel-specific coding. This efficiency drastically reduces time to market and eliminates duplicate system testing across different platforms. This is a Hebrew architectural blueprint of an actively deployed framework. It visually maps the exact structure we just built: the decoupled process layer, the generic AI mediator, and the demoted CRM. The ultimate test of this structure is future-proofing. What happens when AR glasses or a new IoT interface becomes the next mandatory channel? Because business logic is isolated, generic, and strictly decoupled, any future channel simply plugs directly into the shared process layer. This guarantees total technological agility for the enterprise.